Welcome again, Bright Mind Academy, where we bring brilliance to every lesson. So let's look at another question for question 8, a galvanic cell. So a galvanic cell is set up using a nickel half cell and a silver half cell, okay? So between silver and nickel, we need to know which one undergoes reduction, which one undergoes oxidation so that we see the reduction half cell and all of that. So let's locate our table 4b and then remember here is my nickel that I'm talking about, and then here is my silver. So remember, we use this is only applicable for table 4b. I don't know how it's applicable for table 4a. For table 4b, we use my C method where we say, okay, this starts from there to there to there to there. I think for table 4a, you'll do this and start. I don't know. Yeah, but I don't know. Table 4a, 4b. And then what does it say? It means this one direction goes there. You're gonna write it from like that, and then so this one is gonna be nickel forming nickel 2 plus 2 electron, and then this one is gonna just go in that direction as it is like that. Ag plus electron forming me Ag plus, right? So can you see this one undergoes oxidation? Why? Because Ne moved from Ne0 to Ne2 plus. Okay, so there was an increase in oxidation number. Okay, or it lost electrons. Remember, according to oil rigor, okay, loss of electron, oxidation is loss. Okay, so this one lost electron, so this one undergoes oxidation. So and where is it now? This one undergoes oxidation, so it's gonna be nickel undergoing oxidation. Okay, so I'm gonna say this is an ox, and remember an I it is negative, so this one is gonna be positive. It is gonna be and what a red cat. Reduction is reduction cathode, so it's gonna be okay. This is just Mg plus Ag plus here, so it's gonna be Ag. Remember, reduction is loss of, so reduction is gain of electron, and reduction it is a decrease in oxidation number from Ag plus to Ag. So I think we are done. We are done. So the question says, which electrode, Ni, nickel, or silver, must be connected to the negative terminal of the voltmeter? So which one? So we're gonna say it is nickel. Like here, we're gonna say it is nickel. The reason we're gonna say nickel, or you can say it undergoes oxidation. Okay, it undergoes oxidation, or one might say it is a stronger reducing agent. Remember, a stronger reducing agent. If you are a stronger reducing agent, remember what is an agent? An agent, it is someone who makes something to happen. So if you are a stronger reducing agent, it means you are strong. You are causing other people to undergo reduction because you are an agent to cause other people to undergo reduction. Okay, so you are making the element or whatever thing that you are reacting with to undergo reduction. So if you make other to undergo reduction, it means when I will go what oxidation. So hence we say nickel, it undergoes oxidation, or it is a stronger reducing agent, or it has a higher reducing ability. I move on. Write down a cell notation for the galvanic cell. A cell notation. Well, remember, how do we write a cell notation? A cell notation we start with a what? We start with a anode, salt bridge, cathode. Okay, and then what is our anode? Our anode, it is this one. Okay, anode. So we're gonna say we start with nickel, which is a solid. Okay, and then even if you do not include the cell, the phase, guys, it's fine. And then the line represents the phase change, meaning you're moving from solid to nickel 2 plus, which is now my aqueous, and then your salt bridge. Okay, we are moving from this side separated by a salt bridge, and then on this side we are having what? We start with this one, the reactants, and then we go to the product. So it's gonna be Ag plus phase border to Ag. Okay, let me just say be consistent because I was okay. So this is like 3 marks, all this side. Okay, 1 mark, all of that side. Correctly, so 1 mark, salt bridge, 1 mark. You can ignore, you can ignore phases, okay, such as Ag, such as aqueous or solid. You can also ignore the concentration because sometimes you can write it you're having a concentration. And then calculate the initial reading on the EMF. Initial reading on the EMF, E naught of the cell, it is equal to E naught of reduction. E naught of reduction minus E naught of oxidation. Let's look. The reduction, it is how much? Here is our reduction. This is our reduction. It is 0.80. This one it is. So you're gonna say reduction, it is 0.80 minus negative 0.27 if I saw well. For oxidation, this one, yes, minus into negative 0.27. So when I do my mathematics beautifully, it becomes 1.7, 1.07 or 1.7. Let me quickly punch my calculator and confirm. uh, where is it now, my calculator? Okay, let me do this manually. Okay, 701. So 1.07 volts, by the way. So it's that. Okay. Yes. Let's see if my calculations are not deceiving me. You know, calculations can deceive you. Okay. And then we are fine. We move on. So we found that the initial cell, it is something like, don't forget to include volts, okay? So we mark this, the formula. Yes. How will the voltmeter reading be affected if the concentration of silver is increased? Now you need to write down the full net cell so that you understand this question. The net cell it is, okay, you're gonna multiply this by 2. Okay, let me change color. You're gonna multiply this by 2 such that it becomes the electrons balances. So it's gonna be 2 Ag. So when you write your net, it's gonna be 2 Ag, the left hand side, plus, and then the left hand side of the nickel, it is just plus Ni, and then the right hand side here is just Ag. Okay, sorry, 2 Ag, and then this one it is nickel 2 plus. And then the question is, what will happen if now, how will the voltmeter reading be affected if the concentration of silver ions here, they increase? Remember, we're going to reason using Le Chatelier. Okay, they don't need reason. But if you increase now the concentration of Ag plus, you're going to favor the forward reaction. And when you favor the forward reaction, what happens? You are speeding up the reaction. So it means now the voltmeter reading will do what? Will increase. I hope it makes sense. Let's move to another question 8. Okay, I'm doing two at the same time because they are not that long. So it says now this one, the balanced chemical equation represents a reaction taking place when a galvanic cell is operating under standard condition. Okay, what are standard conditions? Concentration of 1 mole per decimeter cubed, temperature of 25 degrees Celsius or 298 Kelvin, or pressure of how much? 1 atmospheric pressure or 1.1.0, okay, kPa. But this one we only use it if and only if there is gas. But this one is applicable for everything, okay? This one, if okay, these two are applicable for everything including gas. This one is applicable for only gases. Okay, for gases this one is applicable, this one is applicable, also this one. So for gases we have three, for others we have, for aqueous and others we have only two. I hope that makes sense. And then the initial, we are given the E naught of the cell to be 0.14. So we have now 6Cl minus to Au 3 plus C2 blah 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 blah. So now let's analyze this one. Cl minus goes to Cl. Cl2, it is just a pure element, so it is 0. So its oxidation number moved from negative, from minus to 0. So from -1 to 0, it is an increase. So the one that undergoes an increase in oxidation number, an increase in oxidation number, it is oxidation according to the definition. So it means Cl undergoes oxidation, and oxidation is loss of electron. So okay, I want to believe it should be like that. And then sorry, a little bit. And then let's look at this. This one is Au3 plus that we do not know, and it undergoes reduction. How do I know? Its reduction oxidation number moved from 3 to 0. So it is a decrease. So a decrease in oxidation number, it is reduction. So reduction is also gain of electron. So it means Au3 plus gained those 3 electrons to form what? Au. Never mind the 6 and the 2 and the 3 and these ones. Never mind the coefficients. They are just balancing out there. Okay. Yes. So write down the standard condition under which it operates. So remember, here there is no formation of gas, so we are only restricted to concentration of 1 mole per decimeter cubed, and or you can say, and what temperature of 25 degrees Celsius or 298 Kelvin. Okay, you cannot use here pressure because why? There is no a gas here. For this cell, write down the name of the formula, name or formula of an electrolyte that can be used in the salt bridge, an electrolyte that can be used in salt bridge. Normally for an electrolyte, you use things such as potassium nitrate, sodium chloride, uh, uh, I don't know. You can use any nitrate, okay? Any soluble salt, basically. Any soluble salt. Okay, let me say any soluble. What do I mean any soluble salt? Any soluble salt, it is a salt that does not form a precipitate. Okay, we cannot use silver nitrate. Silver nitrate causes us or forms us forms us a precipitate. So not this one. So I prefer you to stick with potassium nitrate. It does not. It is always applicable everywhere. A reducing agent. A reducing agent, remember I said when you are a reducing agent, it means you are undergoing oxidation. Okay? Basically, they are trying to find the one that undergoes oxidation. Okay? Which one undergoes oxidation? Which one undergoes oxidation? Okay, the one that undergoes oxidation is the one that had an increase in oxidation number. Which one had an increase in oxidation number? When we check that this is Cl minus. How do I know? Cl minus had an increase of Cl minus to Cl2, which is 0. Okay, so from minus to 0, it is an increase, because from negative to positive, it is an increase. So Cl minus is our what? It is a reducing agent. It was a reducing agent is not the one that is reduced. A reducing agent is the one that is oxidized. So which one is oxidized? Cl minus is oxidized because its oxidation number increased from -1 to 0. Hopefully you understand. If you not, please check the video under redox reaction from grade 11. Okay. Cell notation. Cell notation. Before we do anything, we just confirm. Are we having any solid? So are we having any gases? No. Are we having any element that moves from aqueous to aqueous or that does not change a phase? No. Guys, I do have a gas here. If I do have a gas, it means now I can say pressure of 1 atmospheric pressure or 101.3 kPa. You know, guys, sorry about that. I do have a gas there. So remember a cell notation when I have a gas. Okay, I'm gonna write it here. When I have a gas, the cell notation is gonna look like this. The side with a gas, I'm gonna show you. Remember, we start with the what? The anode. Okay? What is our anode in this case? Our anode is this one. So it is Cl minus, which is just in aqueous, and then it moves to Cl2, which is my gas. But remember, I said when I have a gas, since well there is no solid, I need to put now my what? My platinum cathode to act as a cathode again, and it should be a solid. My platinum cathode. Sorry, my platinum electrode. Okay, remember I need my what? I need my electrode. Okay, my electrode here need to be what? Need to be uh solid. Okay, needs to be solid. They need to be solid, by the way. Okay, and then so hence we add pt there because when we check here there is no solid, so we need to add an electrode. And then the one that undergoes this one, okay, we just say Au3, which is just an aqueous, to Au, which is just a solid. And then calculate the standard reduction potential for Au. So remember, we are already given E naught of the cell. It is equal to E naught that undergoes reduction minus E naught that undergoes oxidation. E naught we are already given to be something like 0.14. Then the reduction part, which one undergoes reduction? It is the Au3 plus, so we do not know. So I'm going to say E naught of reduction, put it like that, minus E naught of oxidation. Oxidation, it is this one. So where is the Cl minus? We are using this one. So it is 1.36. 1.36. And then when you do mathematics, you get to see that it is, this is negative. When it goes to the other side, it's going to be positive. So it's going to be 1.5 volts. So 1.5 volts. Do we have 1.5 volts here? I doubt. I doubt. So it is just an element that we do not have. Okay. So yes. So that's that, guys. That's that. Another thing here, before I forgot, here the one that you can see that undergoes cathode and oxidation. Remember, every time we are forming on the cathode, whatever that you are trying to form, we are forming on the cathode. So it means, can you see here? Here it is slim. It tells you that there was a decrease in mass. So there was a decrease in mass in an oxidation. If oxidation occurs, remember we are moving from a pure element to ions. So we are breaking down that element. So we are decomposing it to ions. So hence now it becomes slim, or it loses. Okay, it loses. But this one gains. Why does it gain? It gains because now we are moving from ions, okay, now adding electrons, we are forming pure substance. So when we are forming pure substance, it's going to accumulate there my silver and it will increase. But yeah, so that's that, guys. Hopefully you understood and enjoyed the session. So thank you.